What if there are other universes where gravity works differently, where the laws of physics are different? What would those universes be like? Would life still exist? Is it possible for human imagination to even conceive such universes? At least that's what we observe. But could there be other universes with different laws of physics? With different constants, say a universe where gravity is much weaker or where the speed of light is different? The answer might surprise you. It's yes, but with a catch. Let's try. Or why doesn't our universe just collapse into a big crunch when all the parallel universes collide? Most versions of the multiverse theory assume that each universe is either closed, meaning it's a self-contained bubble with its own beginning and end, or open, meaning it has no boundaries and extends infinitely in all directions. In either case, there's no reason to think that the universes would collide. Also, make sure to subscribe for more videos about space and science. Thank you for watching. It's like asking why don't the sides of a box intersect when you move it to the left? They don't intersect because they're not intersecting in the first place. Well, here's the catch. These other universes are unobservable. They don't interact with our own. It's like trying to touch the moon. Or can they? Some physicists have speculated that there might be ways to indirectly detect these other universes, such as looking for gravitational waves or particles that leak through the barriers between universes. But so far, there's no evidence of any kind of interaction between our universe and other potential universes. You can see it and you can calculate its path, but you can't actually feel it unless you're a rabbit. Similarly, we see and observe other universes unless we somehow send a signal or information across the barrier that separates them from ours. And since there is no known mechanism for doing that, these other universes are forever hidden from our view. We know that our universe is governed by the laws of physics, a set of rules that apply everywhere and at all times. Let me explain. You see, the laws of physics are mathematical expressions that describe how the universe works. It's just based on interpretations of quantum mechanics and theories of gravity that have not been proven or falsified by observation. However, it's just an intriguing concept that captures the imagination and inspires scientists to think beyond the limits of our own universe. Who knows? Maybe one day we'll find evidence of other universes, or maybe we'll discover that our own universe is just a tiny part of a much larger multiverse. Until then, the laws of physics will continue to be a source of wonder and discovery for humanity. Each of them is a potential law of nature. And each of them could be true in some universe. For example, in one universe, gravity could be described by this equation. In another universe, it could be described by this other equation. And in our universe, it happens to be described by this one. We call these universes parallel universes because they exist alongside each other, just like parallel lines in math. They tell us how things move, how they interact. In the early 1960s, a physicist named Hugh Everett III developed the many worlds interpretation of quantum mechanics, which postulates the existence of parallel universes. According to this theory, every time a quantum event occurs, such as the collapse of a wave function, the universe splits into many branches, each representing a different outcome. This means that there are other universes where different versions of you made different choices, had different experiences, and lived different lives. Some of these parallel universes may have different laws of physics from our own. For example, Newton's law of universal gravitation tells us that every object in the universe attracts every other object with a force that depends on the masses of the objects and the distance between them. This law works well for most everyday phenomena. We can predict when an apple will fall from a tree or the moon will crash into the earth. But it's not the only way to describe gravity. There are other mathematical expressions that also work, like Einstein's general relativity, which is more accurate for very massive objects or very strong gravity. But here's the interesting part. There are an infinite number of mathematical expressions that could describe gravity or any other physical phenomenon. You might think that this is just a mathematician's fantasy, but it's actually a serious scientific theory. But you may be wondering, if these other universes exist, why don't we observe any evidence of them? As for the universes colliding, that's also unlikely to happen. So yes, there could be other universes with different laws of physics, but we can't observe them and they can't affect us. In conclusion, the idea of other universes with different laws of physics is mathematically possible, but it's also scientifically speculative. If you enjoyed this video, please leave a thumbs up.